Hello, folks. First thing we're going to do today is we're going to pick it up where we left off with the last trig equations video. And I'm just going to introduce you to some different types of trig equations, ones that we kind of have to think about in terms of our domain. So just a quick review. So when you want to solve a trig equation, there's a couple things that you need to think about. So step one, you have to solve the equation, right? So you have to think about, is this supposed to be a quadratic? Is it supposed to be linear? Is there some kind of factoring I need to do? Do I need to group like terms? And so on and so on and so on, right? So you got to think about, how am I going to solve the equation? Once you have it arranged in a way that can be solved, then you have to figure out your reference angle, right? So once you know what sine theta or cosine theta is equal to, then you have to figure out, all right, well then in that case, what's my reference angle? Once you know your reference angle, you got to figure out your quadrant by the sine, and then from there can use your cast rule, right, to tell you which quadrant it's in. And then once we know the quadrant, we're going to find all possible solutions, right? So we did that in the last video. So now let's take it kind of one step further. So for now, let's just take a look at something similar to what we did in the last video, right? So for example, if I have tan x equals 1, right? So it's already been isolated, right? Tan x is already isolated here. So now we need to figure out, well, what is x? And in this case, we have to use our special triangles to say, well, we know that tan x is equal to 1 when we're talking about pi over 4, right? And that would be our reference angle, pi over 4, right? Because if you think about the pi over 4 triangle, it's 1, 1, root 2. So 1 over 1 gives us the one that we're looking for, right? And now we need to think about, which quadrant are we in? So since it's a positive 1, we're going to be here in quadrant 1, and down here in quadrant 3, where this angle here is pi over 4, and this angle here is pi over 4 as well, right there and there. Now that I know I'm in quadrant 1 and quadrant 3, I'm trying to solve for all possible answers from 0 all the way to 1 full rotation to pi. It happens twice, so we'll have 2 answers. So our answers here are x equals pi over 4, and x equals, this is pi here, so if I go one more quarter of a pi, so quarter of pi, 2 quarters, 3 quarters, 4 quarters, 5 quarters of pi, so we get 5 pi over 4. Okay, so nice and simple, that one. Just one of the basic equations, what I mean by simple, right? And then it gets a little bit more difficult as the question goes on. So for example, if I wanted to solve something like this, where we have sine squared x is equal to 1/2, right? So again, what I need to do is isolate the sine x. So we're going to take the square root of both sides. So the square root of this side, the square root of that side, and we get sine x is equal to 1 over root 2. So now this is one of those situations where you have to be careful, right? A really common mistake is say, all right, well, here's my answer. But we have to be careful because not only is 1 over root 2 an answer, but so is the negative of 1 over root 2, right? Because if I square negative 1 over root 2, I get back to 1/2, right? So again, it's a matter of thinking about it as two kind of separate questions. So first off, we're going to figure out, all right, well, when does sine x equal positive 1/2? And when does sine x equal negative 1/2? Right, so that's what we need to figure out now. But before we do that, we also have to kind of take a look at our domain. Notice with this question, with the previous question, our domain was from 0 to 2 pi. But now with this question, there is no domain. So we're looking for all possible answers. So again, what I need, sorry, there should be square root of 2 here, my bad. We got to think about which triangle this is. So again, this is my 30-60 triangle. I'll use degrees just for your guys' comfort here. I could just easily use radians. So if this was 30, 60, 1, sorry, that's my mistake again. My goodness, I'm having an off day today. This is the 45, where 1, 1, root 2, right? So then my reference angle here, x, is 45 degrees, right? That's my reference angle, x reference. And then we have to use our cast rule to figure out what quadrants we're in. So for positive x, right, so for this one here, we'd be in quadrants 1 and 2. And then for negative x, we'd be in quadrants 3 and 4. Right? So now, for our answer, we're going to use this notation here. X is equal to 45 degrees plus 360 degrees n, where n is a integer, meaning that 360 times 0, 360 times 1, 360 times 2, 360 times 3, 360 times negative, right? It's all integers. Now, that would be the answer for this terminal arm right here, right? And then we'd find the answer for that terminal arm, and then we'd find the answer for this terminal arm and this one, and we'd see that there's 4 answers. But you have to be careful, because if we can simplify this, we really should, right? So, for example, if I were to just look at the angle that it takes to go from this terminal arm here to this one here, what we'd find is that's 180 degrees. And then to go back is another 180, then to go back is another 180. So with this question, it's not going to be 360n, it's actually going to be 180n, because that's how much we need to go to get to my next answer, right? Same thing is going to be true with this one. X is equal to 180 minus 45 is 135 plus 180 n, where n is an element of the integers. Okay, so let's keep going. So now we get into these questions where it's like, wait a second, I've got tans and I have secants. So how do I deal with a question like this? And for this question, what we need to do is we need to think back to our identities. We don't want multiple trig identities in here, trig functions in here, if we can help it, right? So for example, tan squared is 1 minus secant squared. So now, right, that I know everything's in secant squared, now it would just be a matter of isolating my secants, right? Getting my secant squareds by themselves. So secant squared x minus 2 secant x, and then positive 1 and negative 1 end up canceling, so then this thing is equal to 0. So then what I get is secant x, if I factor it onto secant x minus 2 is equal to 0. So again, what I find is that there's kind of 2 scenarios that I need to solve for. I need to solve for, well, when does secant x equal 0? And when does secant x equal 2? Right, so now solving for when this thing is 0, right? So remember, secant is 1 over cos, right? So we have to be careful. So we got to think about, well, when does secant x equal 0? And here we got to think about when does secant x equal 2. So what I could do here is I could say, well, when does cosine x, right, take the reciprocal of both sides, equal 1/2? And that might make things a little bit easier for us to solve. Now, be careful here. When does secant x equal 0 is telling us when does 1 over cosine x equal 0. And can 1 over cosine x ever equal 0? No, right? So this one down here will be some value between 1 and negative 1. And if you take any number between 1 and negative 1 and you divide 1 by it, it's never going to equal 0. So this one actually has no solution. So it's just a matter of solving this one over here. So now, again, we need to think about when does cosine x equal 1/2. And again, it's up to you. Kind of, the question doesn't say use radians or use degrees. So I'll use radians this time, right? So we know 2, 1, root 3. So cosine is up here. Said I'd use radians and I didn't. 2, 1, root 3. So we're at pi over 3, right? So that means x is equal to pi over 3. But again, that's our reference angle. So now we need to check with our cast rule to say, okay, well, pi over 3 we need it to be positive, so it's going to be pi over 3 up here, and then cosine's also down here, pi over 3. Right, so our answer is x is going to be equal to pi over 3 plus 2 pi n, where n is an element of the integers. That's for this first terminal arm here. And then the second one down here in the fourth quadrant, x is going to be equal to, so this is 2 pi, right? And it's pi over 3 units away from it. So if this is 6 pi over 3, then this will have to be 5 pi over 3 plus 2 pi n, where n is an element of the integers. Okay, so this one here is a little bit strange because notice how the x and the 30 and the 3, they're inside my sine, right? They're inside this sine operation. Now, it's still equal to 1/2, which is kind of nice because that is one of our special triangles, right? If I had 1, 2, root 3, I'm going to work in degrees here because we're being provided with degrees in the question. So 30, 60, right? So what that means is if I take the inside of this bracket and I just replace it with another variable. So let's say sine A is equal to 1/2, right? So now what I can say is that my reference angle for A is 30 degrees, right? Which means that A is either equal to 30 or A could also be over here at 150, right? So A could also be 150 degrees, right? So it could either be 30 degrees or it could be 150 degrees. Now, A, if we kind of go back to the original question, was put in the place of this entire thing inside my bracket here. So if we come back and we say, okay, well now 3 onto x minus 30 degrees is equal to 30 degrees, right? And over here, A, 3 onto x minus 30 degrees is I don't know why I put the A there, is equal to 150 degrees. Now, solve for x, right? So if I have 3 times over here, then I'm going to divide both sides by 3. So x minus 30 degrees is equal to 10. And then x is equal to 40 degrees. Do the same thing on this side. So x minus 30 degrees is equal to 50. So x is equal to 80 degrees. Now, be careful, right? Because what we would say previously at this point, say, like if it was just this question where we stopped at A, then our final answer would be 30 degrees plus 360 degrees n, where n is an element of the integers, right? And do the same thing over here. We'd say plus 360 degrees n, where n is an element of the integers, right? But in this case, A, this value that we get here, is 3 times x, right? It's 3 times as big as x. So now what that means is if I find an answer for x, right, if I want to find the general term here for x, I'm not going to add 360 to it, right? I'm not going to do this time because the 360 worked here for an a value that was 3 times, right? It had this factor of 3 that times the x to get there. So what I can do is I can take this 360 and I can actually divide it by 3 and I get 120 n, where n is an element of the integers, right? So this domain that we're talking about, because we had to multiply the x by 3 and in order to get an a value, right, or whatever we had inside this bracket had to get multiplied by 3, what that's going to do is it's going to multiply our domain by 3 as well. So our domain, in order for it to multiply by 3 and get us 360, well, our original domain for x has to be 120. And the same thing is true down here for 80, right? 120 n, where n is an element of the integers. Okay. So maybe before we move on to this, let's try another one of those, just so you guys can see what I'm saying. Where am my here, insert blank page. There it is. So if I wanted to solve something like sine 2x, let's keep it nice and simple. Sine 2x is equal to 1 over root 2. Okay, so now what that means is if I replace 2x with some variable a, we'll use a again. So sine a is equal to 1 over root 2. So my reference angle for a is 45 degrees, right? Because that's my this triangle here, right? 1, 1, root 2, so 45. Okay, so then now I know a is either going to be 45 degrees, right? Because my cast rule, so 45 is here, and then 45 there, or a is going to be 135 degrees. But again, what we know now is we're not looking at a, we want to solve for 2x, right? So let's take 2x and put it back in the place for a. So 2x is going to be 45 degrees, and 2x is going to be 135 degrees, right? And again, same thing, this angle here would have had plus 360 degrees, and same thing with this one, plus 360 degrees n. But what happens is now, yeah, 2x would have the 360 degrees n, right? And this would have 360 degrees n. But then when I divide both sides by 2, I get x is equal to 45 over 2 degrees plus 180 degrees n, right? And the same thing here where n is an element of the integers, right? And the same thing happens this one. When I divide both sides by 2, I get x is equal to 135 over 2 degrees plus 180 degrees n, where n is an element of the integers. Okay, so again, when we're talking about these trig equations that have constants inside of the trig expression here, right inside here, then we have to be careful because this is going to change our domain. The domain for sine a, like this one here for the general term, is plus 360, but as soon as you start throwing numbers in here and changing the like this multiplication, then it's going to also change that domain. Okay. So again, let's do a couple more examples, and then I will leave some practice questions on the teams for you guys to try. Sometimes it can be just as easy as substituting, right? So what is cosine of pi? What is the sine of pi, right? So if we think about our unit circle, pi is over here at -1, 0. We know cosine is the x value, so this is cos x times -1. And we know that sine is the y value, so this is sine x times 0. So now this is negative cosine of x equals 0. So now it's just a matter of finding x. So when does cos x equals 0? It equals, well, yeah, the negative doesn't really matter here because it's equaling 0. So if we make both sides negative, so when does cos x equal 0? It equals 0 up here, and it equals 0 down here. So x is, and again, this is one of those situations where these two values are 180 degrees from each other, right? So it takes 180 degrees to go from this one to this one, then another 180 to go back, and then another 180. So this is x would be pi over 2 plus pi n. Sorry, I said 180, but I meant pi because we're talking about radians, where n is an integer. Okay, do a couple more and then we'll call it a day. Like I said, I'll do some questions for you guys. So a question like this, again, what you need to do is you need to factor it, right? We need to try to get cosine by itself or get it into its factors. So this one, you could go through slide and divide, but we should be getting familiar with the idea that this is a prime number and this is a prime number. So this is going to have to be 2 cos x and cos x in order to get 2 cos squared x. And now these two numbers here are going to be some combination of 2's and 1's, right? And it looks like this is -2 minus 1, right? Because -2 times 2 gives me 4, -1 times 1 gives me -1, and -4 and -1 is where I get that -5. So now it's a matter of solving these two brackets for 0. So cos x is equal to a half, and cos x equals 2. Cos x equals 1/2. That's one of our special triangles, so we can solve that one. Cos x equaling 2. This one will have no solutions. The reason it has no solutions, both sine x and cos x are always between -1 and +1, right? Sine x and cos x can never be less than -1. They can never be more than 1. So when I see a question like this where I get cos x is equal to 2, right away I know there's no x values that's going to satisfy this equation. So then let's go over here. Again, this is my pi over 3, right? So x, my reference angle for x is pi over 3, right? So if we're looking at our cast rule, it's pi over 3 here, it's pi over 3 there. So we have x is equal to pi over 3 plus 2 pi n, where n is an element of the integers. And down here in the fourth quadrant, we have x is 5 pi over 3 plus 2 pi n, where n is an element of the integers. All right, one more question. So again, what we see here is now we have a 2x. But just because we have a 2x doesn't mean that we have to do the one like this, where we had 2x and we have to kind of think about our domain and change it. What we can do here is we have an identity for 2x, right? So sometimes, especially where I have this cosine here, right? Sometimes we can't just deal with this because we might have another term that doesn't have a 2x, right? So for this one, what I would do is I would use my identity. So sine 2x is equal to 2 sine x cos x minus cos x. And this thing will be equal to 0. Now, let's solve. So if I factor out a cos x from both sides, cos x times 2 sine x minus 1 is equal to 0. Now I see that cos x equals 0 and sine x equals 1/2. All right, so now it's a matter of solving for x for both of these situations, right? So sine x equaling 1/2, that gives me a reference angle of pi over 6, right? Cos x equaling 0, right? So again, when are my x's 0? There's 0 here up at pi over 2, and there's 0 down here at 3 pi over 2, right? So that means x is going to be equal to pi over 2 plus pi n, where n is an element of the integers. And for this one over here, my reference angle is pi over 6. So where is sine positive? It's positive here, and it's positive in the second quadrant. So I get two answers at x is equal to pi over 6 plus 2 pi n, where n is an element of the integers. And I get a second answer at x is equal to 5 pi over 6 plus 2 pi n, where n is an element of the integers. Okay, lots of questions there, lots of examples. What I would like you guys to do is to take a look at the questions I'm going to leave for you in the textbook. And again, the textbook should be on the Teams, and there is an answer key at the back of it there as well. So try the questions, check your answers, make sure that you are getting it. Again, what I'll do is I'll post like a little assignment to go along with it. And this is going to be it for this week. We're just going to take a look at some trig equations. Next week, we're going to start with trig graphs. And this is a really good intro into trig graphs because we're going to take a look at what happens to the graph of these things when we start changing this stuff in the inside here too. Okay, so hopefully we're not struggling too much. If anyone has any questions, feel free to reach out. Maybe we can schedule a time to have a little kind of one-on-one call. Otherwise, if I don't hear from anybody, I will see you on Wednesday. Have a great